round two with neurons. Today's we're gonna kind of focus a little bit more on communication of those neurons, right? And we're gonna call that action potential. And you might have remembered that term from the last time when we were talking about the axons and the myelin sheaths and communicating and all or nothing and so on. That's what we're talking about right now. We're talking about the ability to send messages from one neuron to another. That's how they communicate. Okay, so here's some of the terms that we'll see go through today. Things like resting potential, graded potential, action potential, sodium-potassium pump, which we'll get to and spend some time explaining, and your excitatory, inhibitory, synaptic potential, polarization, depolarization, all or nothing principle, and refractory period. Those are some of the big ones, okay? Threshold as well. All right, here we go. That is a neuron. Crazy, right? How small they are, because that is the head of a needle. Okay, being able to point a neuron out. Like I had mentioned, they can be as small as millimeters to, your nerves can be as long as your central nervous system and or some of your peripheral nerves running like all the way down your leg. Okay, and we'll actually see some pictures of that in a later slide presentation. I had the fortunate ability to go see a bodies exhibit where they had bodies that were stripped away of their flesh and had nothing but their nerves that were remaining. In one instance, it's kind of disgusting, but it's also kind of cool. Okay, so right here, you can see everything we're talking about. You can see the soma, the cell body. You can see the axon. It's tough to see the axon terminals, but you can definitely see the dendrites. Okay, so you see a lot of what we went over in the structure and function. So here we are. Let's talk about the communication piece, right? And we were mentioning that it was like magnets that are reverse polarized, pointing towards each other, pushing away. And that's how that potential, that action potential gets shot through the axon, sending the message to the next neuron. And here you kind of see the jumper cables, if you will, and how the positives and negatives, the polarization, as we're going to call it, switches as the message is getting sent down the axon, right, from the soma or cell body to the next neuron's dendrites. And this is all happening, like we mentioned before, in literal milliseconds. So fast that we can't even comprehend it, and we just go about doing things on a normal speed, normal basis. But this is happening all the time. Right now, I'm talking, kind of looking around with my eyes towards the keyboard and moving my hand. That is different systems in play in my brain, working at the same time, and some of them will be on what we'll call autopilot. Others will be more focused, like what I'm trying to say. And all the messages are being sent in fractions of seconds, right? There's no real pause in my speech or motor movements or anything along those lines. It's kind of amazing stuff. Okay. So here's where we're talking about the sodium and potassium pump. And that's where we get our positives and our negatives and pushes that information. So it's a loop that there is these aspects of sodium and these aspects of potassium that are in our neurons. And they kind of control the gates to let in and out the polarization, the positives and the negatives, which ultimately push the message down the axon, right? So you can see the movement of the ions, the potassium and the sodium, creates an electrical gradient that will push it down the axon. So by opening these gates, you create kind of this wind tunnel, is another way to look at it, that pushes the information down. And we'll get there in a second. I'll show you again. But here's where we are, another idea of the inhibitory, I don't know why I keep saying that, and the excitatory synapses. So when messages are going on, they're fighting for attention with the different neurons. Your excitatory synapses are the ones that get the attention, and that is the message that gets passed. So for instance, a lot of times maybe you're talking and you don't realize that something is going on behind you or next to you, Well, it's because whatever you were talking about or focused on got the attention of those neurons, and those are the messages being sent. It's not that you weren't able to understand it or see it or it wasn't around you. It's just they were inhibited. They were not able to get their messages sent. Okay, so the excitatory synapses are the ones that pick up the message and send it down the axon. And it becomes, once you're able to excite the synapse, that action potential is all or nothing. Okay, once you reach the threshold where you recognize it and it becomes excitatory, it's going. It's going to happen. There's no like, oh, never mind, I'm going to stop now. It's going, right? So once that message gets sent, it's sent. So here you are, you can kind of see the excitatory neurons in red. They're getting their messages sent where the inhibitory neurons are not. They're being blocked. Okay, and you see the speed at which this is happening. Okay, the excitatory synapse, and you see where the threshold is, right? That dotted line, and you see all these things that aren't meeting that threshold. All of that is not being sent, right? That's inhibited. You're not going to be taking note of that. Once it hits the threshold, though, see that huge spike? And you can also see from the negative to the positive, where we're talking about that electrical potential. That's where that sodium potassium pump will kind of dump the positives and negatives and roll it on. But we're talking milliseconds, and it spikes and it goes. Okay, spikes and it goes. Okay, and then you've got your inhibitory synapse potential, which leads into your resting potential. So once it gets that message, it's going to take some time off. It's going to need to recharge, basically. And that's why when you've probably heard people talk about being overstimulated, that's what's happening. You're taxing your nervous system because there's too much going on for you to try to pay attention to, and you're not getting the rest needed to properly function. So here we are again. You've got your membrane potential in electricity. Once it gets to the threshold, boom, that spike of action potential happens, and you can see it in less than a millisecond, and then off you go. So you can also see how the refractory period is what we'll call it, where it dips down below your initial level of awareness, right? Your initial membrane potential. And then you're going to be resting. Okay. So here we are. This is what I was talking about before when we were talking about the sodium potassium pump and the gatekeepers, if you will. Okay, so you've got your gate 1, gate 2, your sodium potassium resting. And then once the threshold is hit, you can see that they open and they dump their sodium potassium out. It becomes polarized to kick off the electrical surge, and then it will depolarize to kick off the electrical surge. All the positives get dumped. Then it'll repolarize, okay, with your potassium, and then it'll hyperpolarize at the very end, the refractory period. Okay, so you can see what's open and how it changes, and then the resting period goes back to where you were before, and it happens really, really, really fast. Okay, we're talking, again, milliseconds, and it's tough to even kind of comprehend that. But that's how you kind of roll down with the sodium potassium pump. Okay, and here it is again, 3 different charts for you. You can kind of see how they dump in, dump out. I really like this, the top right chart, because you can see how you're switching those positives and minuses because of the dumping of your sodium potassium out the gates, if you will. Okay, and it moves it down the line in really, really lightning fast speed. And then the bottom, it kind of walks you through it. So the sodium channel opens as soon as the threshold's hit, and then the potassium channel opens right after that. Everything floods out, which is pushing those negatively powered electrodes through, and then you start to close them back up, and then you get your refractory period. Okay, so that's how that works. It is very good to have a basic understanding of the sodium-potassium pump. I have yet to see someone really ask a question about the detailed workings of how the different channels open and sodium-potassium works. It is good to know that the messages get pushed through the axon by the sodium-potassium pump. So that's kind of good news and something to keep in mind when we're thinking about the AP exam and kind of the depth of knowledge that we'll need for all this, okay? And here's that last slide again. You can see the reversal of the polarity as the message gets sent down, okay? All right. So if you got questions, let me know. You can always shoot me a remind message for individual questions. We can do one-on-one conferences at any time or just reply to the message. Let me know if you need anything as we're getting started into the biopsych stuff. I know we'll be seeing each other in some capacity here soon, but I'm available to you all the time. All right.